Hello guys, what's up? Welcome to my channel King Coder. Today I am back with another video of array. In this video we will be solving an easy problem of LeetCode and we will see two approaches. So let's start. Here the question is to find a missing number between 0 to n. So we are given an array of size n and the array contains all elements from 0 to n. But one number is missing. We need to find out that missing number. So if the array is a length of 7, there will be element from 0 to 7. We can see that if array element starts from 0 and array indices also start from 0. So if we can place the element according to its index, then it can be easier to find my missing number. So let's do it. So let's place 0 in 0th index. 1, as we have 1, I will place 1 in 1 index. As we have 2, we will place 2 in 2 index. We have 3, we will place 3. We don't have 4, so we will place 5 instead of this 4. We have 6, we will place 6, and we have 7. As you can see, there are 7 elements. 1, 2, 3, 4, 5, 6, 7. There are 7 elements. 7 elements are in this array. So this will not be used. But 4 is missing. So you can see the array is completely sorted and every elements are according to its indices except this one and this one. So if I sort this array and traverse linearly from starting index, whenever the index number and array elements will not same, I will print that index number. So I will print 4 here. Let's take another example. Let's say I have this array like this: 0, 1, 2, 3. So the indices will be 0, 1, 2, 3. So there are 4 elements. So n equals to 4. I should have 0, 1, 2, 3, 4. These all elements I should have, but 4 is the missing element. But if I sort this array, suppose this is a sorted array: 0, 1, 2, 3. So this is a sorted array. 0 is at its position, 1 is at its position, 2 is at 2 index, 3 is at 3 index. So how we will find the missing number? Missing number will be 4. Missing number will be 4 that is not present in the array. So if I traverse the whole array and we cannot find the missing number, then we will return n, because n will be my missing number. So this is my brute force approach. For in the first pseudocode line we have sorted this array, and then we are running a for loop to traversing all the elements. If the array elements is not equal to the index, then I will return the index. If I traverse the whole array but I cannot find the missing number, then I will return the next index. As we can see here, we have traversed whole array 0, 1, 2, 3, and after these 3 we will return 4 as our missing number. So this is the brute force approach. So let's talk about the time complexity of brute force approach. The time complexity of this program will be big O of n log n for this sorting algorithm, big O of n log n, and for this it will be big O of n for this loop. So the time complexity will be big O of n log n plus big O of n, and space complexity will be big O of 1, as we are not taking any extra space. So let's take a look at the better approach. In better approach, we can swap two values to its correct position. It means if we have 0, then I will compare if 0 at its correct position is that the position is 0 itself. It will say yes, it is at correct position. Then I will check 3. Then I will check 3. Is 3 at its correct position? It will say no. 3 is not at correct position. So I need to swap 3 to its correct position. So 6 will come to the first place and 3 will go to this place. I will again check that if 6 at its correct position, it will say no, 6 is not at its correct position. So the array would look like 0, 6, 2, 3, 5, 1, 7. So 6 at its correct position? No. Then simple swap to the correct position. So it will be 0, 7, 2, 3, 5, 1, 6. So I will check 0 at its correct position, yes. I will check 7 at its correct position. Now I cannot send 7 to its correct position because I have only 0 to 6 indices. So it means if I get a number that is greater than n, I will not swap that. I will swap only the values that is less than n. So I will increase I to I++. Now I will check if 2 at its correct position, yes. 3 at its correct position, yes. Then also I++. 5 at its correct position, it will say no, 5 is not at its correct position. So 5 will be swapped with 1. So the array will be 0, 7, 2, 3, 1, 5 and 6. Now we will check if 1 at its correct position, it will say no, and we will swap 1 to a correct position and this will this. So the array will be 0, 1, 2, 3, 7, 5 and 6. Now we will traverse the whole array. We will check 0 at its correct position, yes, then I++, 1 at its correct position, I++, 2, 3. It will ignore 7 at its greater than n. It will check 5 at its correct position, yes, 6 at its correct position, yes. After that for loop, we will check if nums I not equals to I, then I will return that I. It means 0 at its correct position, so 0 will ignore 1, 2, 3, 7. The indices are 1, 2, 3, 4, 5 and 6. So 5, 6. So here I can see that 4 is not equal to 7. So I will return 4. Otherwise, else I will return n. So let's try to understand this better approach. We have run a while loop because we don't want to iterate I while swapping. After this swapping, I don't know that 3 is coming to this position and 6 is coming to its position. I don't know that 6 at its correct position, so I need to again swap this value. So I am not changing I will again swap this value until it reaches the correct index. It means this position. In this position 1 is at its correct index. So in else part I will just increment I. After this while loop, in this part we have done the swapping. So after this for loop we will check if nums j not equals to j. It means this part nums j not equal to j. So we will return this j, else we will return n. When the array is fully sorted like this 0 1 2 3, the array is fully sorted, but our n is equal to 4, so we need to return that 4 in this. So this is the better approach. Now let's try to code this. So here we have run a while loop. As you can see, we have to take a current index nums of I. So we are checking if nums I less than n and nums I not equals to nums of current. Nums of current is nums of I. It means nums of I. If we take a look at this, what is nums of I and why we are taking this? So 0 1 3 4. Okay, the indices are 0 1 2 and 3. So first we will check if nums of I less than n, yes, and nums of I not equals to nums of current. It means nums of I. So it means if I is equals to 0, then nums of I will be 0 in this case. So nums of I will be also 0. Nums of I is 0, so nums of 0 is 0. So yeah, I will I plus plus. In this part it is also same. Nums of I is equal to nums of current, so I will I plus plus. In this case I is equals to my 2, so nums of 2 will be 3 and nums of I, it means nums of 3 will be 4. So I will swap this 3 with this 4, because if the element is 3, it should be placed at 3 index. So I will swap this 3 to 4. So the array will be 0 1 4 3. I will again check this, but in this case the array if condition will be failed, because nums I is greater than n, so it will fail, it will not run, and the while loop will be terminated here. So after this I will check for nums j not equals to j, because every element is at its correct position and this element is not at its correct position, so it will return 2. So this is the code, this is the approach, this is why this is why we are swapping these values, else we are increasing I, and at last we are traversing the array and check for the unmatched index and element. Let's try to run this code. As you can see, all the test cases are passed, so we will submit this code. So this is our better approach. Now let's look at the optimal approach. So we have this array. The array contains all elements from 0 to n. So we know that if I sum all the elements, that is 0 plus 1 plus 2 plus 3 plus n elements. If we sum n elements from 1 to n or 0 to n, we know that the answer will be n into n plus 1 whole divided by 2. This is the actual sum of 0 to n elements, or you can say 1 to n elements. So in the array we have some similar kind of elements, that is 0, 1, 2, 3, 5, 6 and 7. We can assume that we have all the elements from 0 to 7, and we can calculate the sum of this series. 7 into 7 plus 1 divided by 2, it is, that is 28. Now if I add these array elements one by one, we can get the sum of 1 plus 2 3, 3 plus 3 6, 6 plus 5 11, 11 plus 6 17, 17 plus 7 24. So the sum is 24, and this sum is from 0 to n. This is 28, but array elements sum is 24. So we can see that the sum difference is 4. It means if I add 4, I can get this value. So you can clearly see that the 4 is my missing element. 4 is not in the array, so the difference is become 4. So this is the optimal approach you can solve without using any sorting function. So let's see the time complexity of this program. The time complexity will be big O of n, as we are running for loop only one time, and the space complexity will be big O of 1. So let's now try to code this. So in brute force approach, first we are using this inbuilt sorting function to sort the array. Then we are traversing the array and check if error I is not equal to I, then I will return I. If the whole traversing is done and the missing number is not found, then we will simply return n. So let's try to run this code. As you can see, the every test case is accepted. So I will now submit this code. It is submitted. In optimal approach, we have simply find the actual sum using n into n plus 1 divided by 2, and the sum, that is the sum of the all array elements. So we have run a shortened for loop to calculate the sum of the array, and after that we are returning this actual sum minus sum. So it should return my answer. So let's check. Yeah, it is working properly. Now I will submit this optimal approach. So I hope you enjoyed this video. If you have any doubts, then feel free to ask in the comment section. Like and subscribe this channel to get more videos like this. Thank you.